So here is the graph of g of x. G of x, that's in function notation. So in function notation, usually they start with f of x. After they've used f of x for a while, it goes to g of x. It really doesn't matter what letter it is, but this is function notation. Now, sketch the image graph after each translation. Especially while we're going through questions, I'm going to be highlighting different terminology and different words. Because often in a math class, during the question reading, it's like, okay, this is my time for a break. I can zone out until the teacher shows me how to do it, and then I'll pay attention again. And what that does is you don't pay attention to the words in the question. And you don't even realize it, but you're setting yourself up to fail on a quiz or a test. Because what's going to happen when you get to the quiz or a test, you're going to be like, what's an image graph? Write the equation of the image graph in terms of the function g. I find this one in particular, students ask all the time. What does it mean when they say in terms of? Because sometimes it'll say in terms of the function g, and sometimes it'll say in terms of x. So I find that we really have to pay attention to the key words in a question, because I'm not there to help you on a quiz. I'm not there to say, oh yeah, this is what it means, so you can do it. And that's often the case. You can do the math, but sometimes you forget what the key words are. And then you realize, uh-oh, I thought I knew how to do the math, and I didn't. Well, you still can do the math. The problem is more of an English problem. You didn't pay attention to the key words. So the image graph, that's the graph that we're going to get after we draw the new one. So in the first one, a translation of 4 units to the left. We're going to take each of these points, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Move them all 4 to the left. You can connect the dots just like you did in elementary school. So much fun. And we get our new graph. That would be our image graph. Now it says to write the equation. I'm going to underline the word equation. An equation always has an equal sign. If you write something without an equal sign at this point, you haven't followed the instructions, and that's one of the 10 big errors that they look for at the end of the year on your exam. An equation has an equal sign. So we need to write an equation for this blue graph. It's going to be y equals, and in terms of the function g, means that our equation that we write on the right-hand side of this equation has to have the function g in it somewhere. In terms of the function g means that g has to be in it somewhere. Now, it's been moved 4 to the left. Does that happen inside of a function or outside of a function? Inside the function. And 4 to the left, inside of this function will be x plus 4 or x minus 4? X plus 4. So we've noticed already that stuff that happens inside of the function is going the opposite direction of what you have. So minus 4 to the left, but we write plus 4 inside of that function. And the second one, 1 unit up. I'll do that one in green. I take each of the original points and shift them 1 unit up. Play connect the dot again. And there we have our graph. And writing that equation in terms of the function g, well, up and down would be outside of the function. So here's my function, outside of it, plus 1. State the domain and range of each function. So starting with the blue one. For the blue one, I'm going to write this in set notation. Our domain, those are our x values. They go from minus 5 as our smallest x value all the way up to 2. So in set notation, you could say that x is between minus 5 and 2. So you could write it as negative 5 is less than or equal to x is less than or equal to 2. And our range ranges are y values. Again, I like to think of, try to find your smallest y value, and then try to find your biggest y value. Can you see that this smallest y value is 2, and it goes up to 5? So we can say that y is in between 2 and 5. So 2 is less than or equal to y is less than or equal to 5. Now for the green graph, for the domain and range, I'm going to use interval notation so you get used to that one as well. Again, if we look for our smallest x value here, it's -1. Our largest x value is 6. So it goes from -1 to 6. We use a square bracket to say in the interval that those values are included. And we include every value from -1 up to 6. For our y values, our smallest value is 3. And our largest value is 6. Now that we've completed the question, I'm going to say that these are the questions you can now do to practice, 4, 5, 6, and 7. So the homework questions are always at the end of the section. So that'll start on page 169. And the nice thing about this textbook is the homework questions start on page 169, and then the answers, instead of having to flip all the way to the back of the book, if you just go to the end of the homework section, so on page 176, that's where all of your answers are. So it's nice because when you're checking your answers as you're doing your work, which is a good thing to do, don't do all the questions and then check them. Because if you've made the same mistake in all the questions, then you've all of a sudden got really good at that mistake. And you're like trained. You trained yourself well, so you're going to make that mistake every single time. You want to be checking your answers, so it's nice that it's only a couple of pages to get there. So I'm going to give you some time to work on those. Some people like to write these questions beside their example. And in my notes, I always write the questions that I need to do above the question. And then some people also like to go to the homework and circle those ones so they don't have to flip back and forth all the time. But this kind of tells you, oh, if I want to practice this idea, these are the questions that I can do.